press the bell icon on the YouTube app and never miss another update.
Hello students, so we finish up conditional probability in the last class. Okay, today we discuss one more very simple concept in the probability, multiplication theorem on probability. Multiplication theorem on probability, very simple topic. So we derive the formula by using conditional probability. So according to the conditional probability, everyone know that P of A given B is equal to P of A intersection B divided by P of B. Yes, P of A given B, P of A intersection B divided by P of B. One more you know, P of, suppose B given A, P of A intersection B divided by what? P of A. In these two terms, P of A and P of B, they are not equal to 0. Not equal to 0. These two formulas you already know. These two formulas derive from using the concept of conditional probability. So what I do, I cross multiply it. So then P of A intersection B, P of B into P of A given B, correct? And one more, P of right below, P of A intersection B, B intersection A, arrange both are same, P of A into P of B given A, P of A into P of B given A. Observe here, P of B into P of A given B, P of A into P of B given A. These two formulas are nothing but multiplication formula on probability. These two formulas, one is P of A intersection B. A intersection B means both the events. P of B into P of A given B. P of A into P of A given, provided these two are not equal to 0. P of A is not equal to 0, P of B is also not equal to 0. These two formulas are called multiplication formulas on probability. Multiplication formulas on probability. Okay, so where we use this concept, and one more, P of A intersection B is denoted by simply they write P of AB. Understand? P of A intersection B is denoted by P of AB. So I think where we use, actually still now you are not properly to understand. Just now I derive the formulas for multiplication formula. Where we actually use, observe here, P of A intersection B, P of B given P of A given B, P of A into P of B given A. Where we actually use, we will solve one problem better. Then you are understanding the properly about the concept of multiplication theorem. So in that your textbook, 4 problems are there, 2 from worked example and 2 from exercise. Better first I take one simple problem. Example 8, worked example 8. Observe the problem. An urn contains 10 black and 5 white balls. 10 black and 5 white balls. 2 balls are drawn. 2 balls are drawn from urn, one after the other. one after the other without replacement. Without replacement. What is the probability? What is the probability that both drawn balls are black? What is the probability that both drawn balls are black? See, observe here. An urn contain, it's a jar, contain. Observe, firstly observe the concept. An urn contains what? 10 black balls and 5 white balls. So 2 balls are drawn. Your activity is, we take 2 balls from the jar, urn, one after the other. First we take 1 ball. Simultaneously we cannot take 2 balls. First we take 1 ball. After that we take another ball. One more condition, without replacement. First we take 1 ball. Then we cannot put into the again jar. The activity is already done. What is the probability that both drawn balls are black? So let E be the event. First ball drawn is black. First ball drawn is black. F be the event. Second ball drawn is black. E be the event. First ball drawn is black. F be the event. Second ball drawn is black. What he asked? The probability that both drawn balls are black means we are finding both means what? E intersection F. E intersection F. So which concept we use? We use multiplication theorem. We want P of E intersection F. Okay, then so first I take 1 black ball. That event I call it as E. I take 1 black ball. That event I call it as E. Then I find firstly probability of E. Probability of E. In probability of E is what? So you know favorable outcome is 10. 10 divided by 50. So if you cancel by 2 by 3. Probability of E is what? 2 by 3. First ball drawn. Correct? So then I take 1 more second ball. Probability of F. Probability of F. See, observe here. Already E is occurred. E is given. Correct? Probability of F. E is already occurred. Means it is given. 2 by 3. Data is given. So probability of F already E is occurred. So without replace means, so here also 1 less, 9 divided by 15, 1 less, 14. Probability of F. Probability of F, E has already occurred. So 2 by 3. So 1 minus from the favorable outcomes and 1 minus from the total outcomes. So 9 by 14. What he asked? He asked, what is the probability that both drawn balls are black? So we have to find out this one. According to the multiplication rule, P of E into P of what? F given E. Correct? According to the multiplication rule, P of E into what? P of F given E. So P of E is what? 2 by 3 into 9 divided by 14. If you multiply 18 divided by what? 42. 18 divided by what? 42. So 6 3s are 6 7s. Answer is 3 by 7. So this is what concept of multiplication theorem on probability. Concept of multiplication theorem on probability. So probability of E intersection F, P of E into P of F given E. So why I write P of F given E? Because already E event is occurred. It is a given data. So 9 by 14. So he asked, what is the probability that both, very important, both drawn balls are black? Both drawn balls are black means probability of E intersection F according to the multiplication rule, P of E into P of F given E. So P of E is what? 2 by 3, P of F given E is what? 9 by 14. The final answer is what? 3 by 7. This is what the concept of multiplication theorem on probability. So we write the answer. I think you perfect about the concept. So now I write the answer. Very simple steps, 2 mark question. Just write 2 events, define 2 events. Let E be the event that the first ball drawn is black. So find out probability of E. Probability of E 10 means 10 divided by 15. Answer is 2 by 3. And F be the event that the second ball drawn is black. Second ball drawn is black. So probability of F, already E has occurred, given occurred. So 9 divided by 14. 9 divided by 14. Then right here, according to multiplication rule, P of E intersection F, P of E into P of F given E. So P of E is what? 2 by 3 into 9 divided by 14. So answer is 18 divided by 42. 3 by 7. 6 3s are 6 7s are 3 by 7. So this is what? The answer. So this is what the concept of multiplication rule on what? Probability. So very interesting concept, very simple concept. Observe carefully. So we go for next problem. Next problem in example 9. So first we finish up these 2 worked example problems, then we go for exercise problems. 3 cards are drawn successively. 3 cards are drawn successively without replacement. From a pack of 52 well shuffled cards, properly arranged. What is the probability? What is the probability? The first two cards are kings and third card drawn is an ace. What is the probability? The first two cards are kings and third card drawn is an ace. Okay, so one by one we write the answer. Let E be the event. E be the event that the first card drawn is king. That I written as a probability of E. So in a 52 pack, how many kings are there? 4 kings are there. Yes, in 13 set, 1 1 1 king, 4 sets are there. 4 divided by 52. Fine. 4 divided by 52. Next, F be the event that the second card drawn is king. That also king. First two cards are king. So probability of F already is occurred. So we less because without replacement. 4 minus 1 is 3. 52 minus 1 is 51. 3 by 51. Correct? One more. And G be the event that the third card drawn is what? An ace. Drawn is an ace. Probability of G. Two events already occurred. One is E and another one is F. Both two events already occurred means E intersection F. Probability of G, already both events are occurred. How many A's are there? 4. In the sample base we less 1, 4 by 50. Observe carefully these 3 events, one by one. E be the event, first card drawn is king. F be the event, second card drawn is king. G be the event, third card drawn is an ace. So what he asked, what is the probability that first two cards are king and the third card is an ace? That answer we have to write. Correct? That answer we have to write. Means probability of E intersection F intersection G. Correct? Probability of E intersection F intersection G. According to the multiplication rule, P of E into P of F given E into P of G given E intersection F. G given E intersection F. This is according to the what? Multiplication rule. According to the multiplication rule. So answer 4 divided by 52, 3 divided by 51, 4 divided by 50. After calculating, because this is an worked example problem, 4 by 52, 3 by 51, 4 by 52. So 2 divided by, you also calculate, 2 divided by 5525. 2 divided by 5525. Observe this problem carefully. This is very important for 3-mark question. Very simple concept, multiplication rule. According to the multiplication rule, P of E into P of F given E into P of G given E intersection F, because both events are already occurred. Next problem. So we go for two more problems from the exercise. Exercise 13.2. Two more problems from the exercise 13.2. Under that, second problem. First problem is another concept. Second problem, two cards are drawn. Two cards are drawn at random and without replacement. Without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Both the cards are black. Two cards are drawn at random from a well shuffled pack of 52 playing cards. So you know how many black cards are there? 26 black cards and 26 red cards. Find the probability both cards are black. One by one we write. Solution. Let A be the event that the first card drawn is black. Probability of A. How many cards are there? 26 by 52. 1 by 2. Correct? The first card drawn is black. One more event and B be the event that the second card drawn is black. So probability of B, A has already occurred, means A is given 25 divided by 51. 25 divided by 51. According to multiplication rule. According to multiplication rule, probability of A intersection B. Probability of A into probability of B given A. 1 by 2. 25 divided by 51. 25 divided by 102. Correct? 25 divided by 102. 25 divided by what? 102. That is enough. If you want, you simplified it. This is the answer. See, observe, if you know very well about the concept, you can solve any type of problems. This is the first problem. Next problem. In the same exercise 13.2, third problem, a box of oranges oranges is by inspected by examining three randomly selected oranges drawn without replacement. Without replacement. If all the three oranges are good, all the three oranges are good, the box is approved for sale. Otherwise it is rejected. Find the probability. Find the probability that box containing 15 oranges out of which 12 are good. 12 are good and 3 are bad ones. 3 are bad ones. Will approved, very interesting. Approved for sale. Will approved for sale. See, a box containing oranges inspected by examining 3 randomly selected oranges. If all the oranges are good, then the box is approved for sale. Otherwise, it is rejected. Find the probability, very interesting, that box containing 15 oranges. In that box, 15 oranges are there. Under that, 12 are good, 3 are bad. Once will approved for sale means what we do? We take 3 oranges from this box. All the 3 oranges are good, because find the probability for approved for sale. If it is approved for sale, only when, observe here, if all 3 oranges are good, then the box is approved. That's why what we take 3 oranges, those 3 oranges are good only, not for bad. Okay, one by one event we have to write. Solution. Let A be the event that first drawn orange is good. First drawn orange is good. So probability of A is how much? 12 divided by 15. 4 by 5. And B be the event that second drawn orange is good. So probability of B A has already occurred 11 divided by 14. 11 divided by 14. Correct? 11 divided by 14. Write it above. 11 divided by 14. Here not we write and C be the event that third drawn orange is good. Third drawn orange is good. Probability of C already A and B has occurred. 10 divided by 13. 10 divided by 13. According to multiplication rule, according to multiplication rule, probability of A intersection B intersection C, probability of A into probability of B given A into probability of C given A intersection B. A intersection B. One by one answer. 4 by 5. 11 divided by 14. 30. 5 ones are 5 twos are 2 twos are 2 sevens are 2 into 2 4 into 11 and 7 into 30. 44 divided by 91. 44 divided by 91. See the answer. Okay, so very well concept. So observe first carefully. This finish up multiplication rule. So one more concept in the probability. Independent events. Independent events. Very interesting and very simple concept. One more concept in probability. We finish up two concepts. One is conditional probability, another one is multiplication rule. Third concept, independent events. When we say two or two more than three, just we take two events. This is your concept. In this your textbook only two events are given. So means for 12th only two events. We discuss regarding only two events. When we say two events are independent with respect to the probability. Observe here, I write one simple definition. Let E and F be two events associated with the same sample space. Yes, let E and F be two events associated with the same sample space, yes, then E and F are said to be independent. E and F are said to be independent. Probability of, very observe here, E intersection F, observe here. E and F are said to be independent events. Probability of E intersection F is always equal to probability of E into probability of F. This is the condition. If LHS is equal to RHS, probability of E intersection F is always equal to, what my point? Probability of E into probability of F. If this condition satisfies, we say that E and F are what? Independent events. If it is not equal, E and F are not independent events. Let E and F are said to be independent only when probability of, once again I explain, probability of E intersection F, this result is equal to probability of E into probability of F. LHS is equal to RHS. Here what we got the result, same result here also we got it. Then only we say that E and F are what? Independent events. If LHS is not equal to RHS, E and F are not independent event. This is what the concept of independent events. I think you are understanding. If two events are said to be independent, suppose if two events means, if I take A and B are said to be independent. Once again I explain, said to be independent, probability of A intersection B is equal to probability of A into probability of B. Understand? If this condition satisfies, we say that A and B are two events, and these two events are associated with the same sample space. They are not associated with different sample space, are associated with the same sample space. If this condition satisfies, we say that A and B are what? Independent events. Okay, so after knowing this concept, very simple concept, I can explain in a very simple manner. After knowing this one, we solve some problems regarding this concept. So in the 13.2 exercise, first problem, if P of A 3 by 5, P of B 1 by 5, find P of A intersection B if A and B are independent events. He has given A and B are independent events by definition. Into A of B. He has given P of A is what? 3 by 5. P of B is what? 1 by 5. 3 divided by 25. 1 mark question. 1 or 2 mark question. 3 divided by what? 25. Observe, very simple question. 3 divided by 25. Because if two events are said to be independent, probability of A into what? Probability of B. Next problem. Second and third, just now I discussed multiplication rule concept. Fourth problem. A fair coin and an unbiased die are tossed. Let A be the event head appears on the coin. Head appears on the coin and B be the event 3 on the die. Check whether A and B are independent events. Or not. Very important problem. Observe the problem. A fair coin and unbiased die are tossed. Fair coin and unbiased die are tossed means, firstly write the sample space solution. The sample space S is given by H1, H2, H3, H4, H5, H6. Like that, T1, T2, T3, T4, T5, T6. Let A be the event head appears on the coin. Let A be the event head appears on the coin. Head appears on the coin means what are those events? H1, H2, H3, H4, H5, H6. So N of S, N of S is what here it is 12. N of A is what? 6. Probability of A, 6 divided by 12. 1 by 2. 6 divided by 12, 1 by 2. A is over and B be the event 3 on the die, and I write here B be the event 3 on the die. Three on the die, H3, T3. Okay, N of B is how much? 2. 2 divided by 12, 1 by 6. What he asked? He asked whether A and B are independent. For that, we want A intersection B. In these two terms, only one sample point is there. N of A intersection B, 1 divided by 12. n of A intersection B is 1. Probability of A intersection B 1 by 12. So check whether those two events are independent means those two events are independent only when probability of A intersection B is equal to what? Probability of A into probability of B. We check first P of A. P of B. P of A is what? 1 by 2, 1 by 6, 1 by 12. That is equal to P of A intersection B. That implies P of A intersection B, P of A into P of B. Correct? P of A into P of B. Hence, what is the conclusion? A and B are independent events. Hence, A and B are very simple question. A and B are independent events. Observe this question. Next question. Fourth main we finish up. Fifth main problem in the exercise 13.2. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event. A be the event. The number is even. And B be the event. B be the event. B be the event. The number is red. Number is red. Or A and B independent. What we or A and B independent. What we discussed in the previous problem, same concept. A die is marked with 1, 2, 3 in red and 4, 5 in 6. Solution n of s 6. Correct? N of s is 6. Let A be the event, number is even. Number is even. What are those? 2, 4, 6. N of A 3. Probability of A 3 by 6, 1 by 2. This is over. 3 by 6, 1 divided by 2. And B be the event. The number is red. number is red. What are those elements? 1, 2, 3. N of B 3. Probability of B, again it is 3 by 6, 1 by 2. Then check whether A and B are independent. That means if we want A intersection B is 2, N of A intersection B, it is 1. Probability of A intersection B, 1 by 6. All values are find out. Only one concept we left, whether they are independent or not. For that, P of A into P of B, 1 by 2 into 1 by 2, 1 by 4. It is not equal to what? It is not equal to P of A into P of B. Is it equal? No, not equal to A intersection B. Then what is the conclusion? Hence, A and B are not events. A and B are not independent events. Observe this problem. Next problem. Sixth problem in exercise 13.2. Let E and F be events with three by 5, 3 by 10 and 1 by 5. This is given 1 divided by 5. What he has? Are E and F independent? Are E and F independent? That also you know how to solve. All are given. One by 5 P of E, 3 by 5 P of F, 3 by 10. 3 by 10. Let P of E into P of F, 3 by 5 into 3 by 10, 9 divided by 50. Correct? So, not equal to 1 by 5. E into P of F not equal to. Hence, what is the conclusion? E and F, correct? Hence, E and F are not independent events. Very simple questions. Are not what? Independent events. Next question. Seventh question. Given that the events A and B are such that P of A 1 by 2, P of A union B 3 by 5 and P of B equal to small letter p. P of B is equal to small letter p. What he asks, find P. P if they are, number 1, mutually exclusive, that I already discussed in the first two classes, I think. Second one, independent. Mutually exclusive, already discussed. If two events are said to be mutually exclusive, their intersection is empty, disjoint sets. Here first, mutually exclusive, that is n of A intersection B is empty. Probability of A intersection B is what? 0. N of A intersection B is an empty. Probability of A intersection B is 0. So we have to find out probability of B. Given P of A is 1 by 2, P of A union B is 3 by 5 and P of B is P. So we know that P of A union B plus P of A intersection B, algebra of probability, P of A plus P of B. Substitute all the values. P of A union B is 3 by 5 plus 0, 1 by 2 plus P. So P is equal to 3 by 5 minus 1 by 2. P is equal to 10 is the LCM, 3 minus, sorry, 3 2s are 6, sorry. 10 is the LCM, 5 2s are 10, 3 into 2 6 minus 5 into 1. So answer is 1 by 10. Answer is 1 divided by 10. This is for mutually exclusive events. First question is over. Second one. Independent events. If two events are said to be independent, just now we discussed P of A intersection B, P of A into P of B, correct? So again we know that A union B plus A intersection B, algebra of probability. So P of A union B 3 by 5 plus A intersection B is nothing but what? P of A into P of B. P of A is what? 1 by 2 plus P. 3 by 5 plus 1 by 2 into P. 1 by 2 plus P. So 3 by 5 minus 1 by 2 is equal to P minus P by 2. I shift 1 by 2 P from left side to right side, 1 by 2 from right side to left side. Same what we hit out here, 3 by 5 minus 1 by 2, 1 by 10. 2 is the LCM, 2P minus P. Correct? So 1 by 10, P by 2. 2 ones are, 2 fives are. P is equal to what? 1 by 5. P is equal to 1 by 5. Observe these two concepts. One for mutually exclusive, another for what? Independent events.